Alright, in this video we're going to talk about factoring a trinomial, which is one of the more common type of factoring methods that we tend to see. Alright, so remember, a trinomial is something that has three terms. Right? So the most basic type of trinomial is the one where that leading coefficient, that one that's in front of the x squared, is just a 1. Alright, so this video will just deal with if there's a 1x squared, and then I'll do another video where if there's another number besides 1 in front of the x squared, then it gets a little bit more complicated to factor it. So I'll cover that one in another video. For this one we have x squared plus bx plus c, where b and c are just some real numbers. The b is the coefficient of the x, the c is that constant term that's at the end. Right, so if we want to factor that, remember, factoring is breaking something up into multiplication, one thing or more than one thing multiplied by another. Right, so notice, if we have two binomials, x plus r times x plus s, right, if we multiply those together and we use the FOIL method, what we get when we multiply those, well, when we do the first terms, x times x gives us x squared. When we do the outer and the inner terms, we get x times s and r times x, and those are like terms, so we would add those together. We get r plus s times x. And then when we do our last terms, r times s gives us that r times s at the end. Right, so to get from a trinomial into a factored form, basically what we look for is two numbers. Those two numbers have to multiply together, right? The r times s have to multiply together to equal c, that constant at the end, and those numbers have to add together. R plus s has to equal that b, that coefficient of the x term in the middle. All right, so that's really what we're looking for here, is two numbers that, in this case, for x squared plus 3x minus 18, we're going to look for two numbers that multiply to negative 18 and add up to positive 3. And if we can find those two numbers, well, then we can write these two factors for our expression. All right. Now, when we're doing this type of factoring, it is like we're doing the FOIL method in reverse. Right? We start with something that looks like this, and we want to think, well, what two binomials could I put together here that when I multiply them, I end up with this trinomial. Right? And the way we do that, again, is the last terms that go in our parentheses, when we do the last term of the FOILing, those two multiply together to equal the constant c. And when we do the inner and outer terms, when we add those two together, they have to add up to equal that middle term. So the two numbers have to multiply to equal the c, in this case negative 18, add up to equal the b, in this case that 3. All right, so for this one, x squared plus 3x minus 18. I need two numbers that multiply to negative 18, add up to 3. Well, if you don't see them right away, and it depends on your ability and how well you know numbers and multiplication and all that stuff, if you don't see it right away, just think, well, what numbers can multiply to equal 18? And I can make a list over here. So it could be 1 times 18, it could be 2 times 9, it can be 3 times 6. And notice, I'm just kind of going in order. I start with 1, then 2, then 3. 4 does not divide evenly into 18, so 4 is not going to be on the list. 5 does not divide evenly into 18, and then the next number, 6, is already on the list. So these are all the numbers that will multiply together to give me 18. All right, now, so if I'm going to be able to factor this, the r and the s, those numbers that finish off my factors, are going to be one of those pairs. Well, the question then is, well, which of those pairs can add up to a positive 3? Well, as they are, none of those add up to positive 3. But remember, these have to add up, or these have to multiply to a negative 18, right? Which means one of these numbers that I have here has to be negative. And for this last one, if I make it a negative 3 times a positive 6, that's going to multiply to negative 18. And when I add negative 3 plus positive 6, that's going to add up to a positive 3, right? So, when you're doing this type of factoring, if you don't see right away what numbers are going to work, you can make a little chart. Negative 18, what numbers multiply to 18? And like I said, start with 1, 2, 3, 4, 5, and just see if they divide into 18 evenly. And then they have to add up to equal 3. Right? 1 and 18 are not going to add up to 3. 2 and 9 are not going to add up to 3. But 6 and 3 will if I make that 3 a negative. Right? So then, when I go to write my factors, the x squared, remember, I break that up into just x times x, right? When I do my first terms of the FOILing, x times x is going to give me the x squared. When I do my last terms, these two numbers multiply to equal negative 18, so it's going to be a minus 3 and a positive 6. And then when I do the rest of my FOILing, my inner and outer terms, right? When I do the inner, that's negative 3x. When I do the outer terms, that's positive 6x. And those two add up to equal positive 3x, which lets me know that this is my correct factoring of x squared plus 3x minus 18. All right, so this type of factoring method, like I said, is probably one of the more common ones that you'll see. It's also not that hard to really do, provided the numbers aren't like ridiculously large. If you have numbers in like the hundreds or the thousands, then doing this type of factoring is a lot more difficult because you have a lot more choices of numbers that might multiply together to give you the one that you want. So depending on what the numbers are, this could be harder or easier. But that's basically what you do. When you recognize that it's a 1x squared, I just look for two numbers that multiply to this number and add up to this number, and those are the numbers that I put at the end of each parentheses with just that single x in the beginning. And just like with any other factoring method, if you want to double check your work, you just multiply it back together. Right? In this case, if you FOIL it, you get x squared, you get plus 6x minus 3x, which is plus 3x, and then negative 3 times 6 is negative 18. All right, so that is factoring a trinomial when it's just a 1x squared. All right, if we look at another example of this, and if you would like to, if you feel comfortable with what we just did there, maybe you want to pause the video here and try to figure out this next one on your own, the x squared plus 15x plus 56. See if you can figure that one out and then play the video and see how I do it and make sure you come up with the right answer. So x squared plus 15x plus 56. Again, it's a 1x squared, which tells me that I can just go ahead and set up my two factors. Since it's a 1x squared, I know my first terms of each factor have to be x times x, because that's the only way when I multiply them together, it's going to be x squared. And then my last two numbers have to multiply to equal positive 56. Right, so they have to multiply to equal positive 56, and they're going to have to add up to equal positive 15. All right, so positive 56 is a pretty big number. There's probably a lot of different numbers that can multiply to equal 56. So if you don't see what those numbers are right away, start making a list, right? If you see it, like some people can look at this and say, oh, I know exactly what those numbers are. Just go ahead and put them in the parentheses, and you don't need to do all this stuff over here. All right, but again, if you don't see it, start your list. So, well, 1 times 56, but those are not going to add up to 15, so that's not going to work. 2 times 28 would be 56, but 2 and 28 also don't add to 15. Let's see, will 3 go into 56? It will not. 4 will. All right, it's going to be 4 times, what, 14? All right, but 4 and 14 also don't add up to 15. Let's see, 5 will not divide evenly into 56. 6 will not divide evenly into 56. 7 will. All right, it's 7 times 8 gives us 56, and 7 plus 8 gives us positive 15. All right, so those are the numbers that I need there. Right, and when you use this method, like the 2 times that I did this here, it was the last one that ended up on the list, which is the one that worked. It's not always that way. Sometimes it's that first one. Right, if this had been like a plus 57x in the middle, well, 1 plus 56 equals 57, and so that would be the one that I want. And once you find the one that you want, you can just stop the list, right? You don't have to list every single set of factors that equal 56. You just need to find the one that's going to add up to 15. If that happens to be the first one you put on the list, then you're done. All right, so I got my 7 and 8, so to fill in my factors there, it's just going to be x plus 7, x plus 8. It's all positive because they have to add up to a positive 15, they have to multiply to a positive 56, so it's just x plus 8, x plus 7. All right, so when you're doing this type of factoring, you do have to pay attention to the signs. If one of these numbers here is negative, you got to make sure that it multiplies correctly and it adds up correctly. It's one of the most common mistakes people make is just messing up the signs in a problem like that. Also keep in mind that when you're doing the factoring here, the order that you put them doesn't matter. In other words, I wrote this as x plus 7, x plus 8. If you had written it as x plus 8 times x plus 7, that's also correct, right? Remember, multiplication has that commutative property that you can switch the order. 5 times 3 and 3 times 5 multiply to equal the exact same thing. Same idea with factors. And with this one up here, if you had put x plus 6 first and then x minus 3 second, it's still correct, right? There's no one way you have to write it. Some teachers out there might be particular about the way that it is, but either way is correct, no matter which order you write those factors. All right, so that's factoring a trinomial. When you have a 1x squared, you just look for two numbers that multiply to equal the last number, add up to equal the number in the middle, and those are the two numbers that kind of fill out your factors with the x's in the front. And remember, if you want to check, if you do the FOIL method to check it out, all right, x times x is x squared, x times 8 is plus 8x, x times 7 is plus 7x, right? That's why we look for two numbers that add up to equal the one in the middle, because when we actually FOIL this, the x times 8 and the x times 7, those are always going to give us like terms, and so we're always going to add those together. So the 8x plus 7x has to add up to the 15x, right? That's why we look for the two numbers that add to 15. And then the last terms, the 7 times 8 is 56. right? That's why we look for two numbers that multiply to 56, because when we do that last term of the foiling, it has to equal that one that we have there, right? So if you understand that's what we're doing is the FOIL method in reverse, it makes it a little bit easier to understand how to approach factoring something like this. And then the rest of it is just being able to find the correct numbers. That's knowing your multiplication tables and being able to factor just plain numbers, and then find the combination that works out just right. All right. In the next video that I do, we'll look at factoring trinomials where we have not just a 1x squared, but some other number in front of the x squared. That's what we call the AC method. So check that one out, because that's also an important method to use for factoring.